Hi, everybody. This is Miss Scripa. Today, our assignment was, let me find out, the very last one about food webs that we're going to be doing. So we've spent 3 different class days on food webs, and we're going to move on Wednesday this week. So I just want to be sure that we're doing okay and we're in a good place with food webs before we move on. So I'm going to go over these 2 open response questions with you really quickly. The number one thing to remember when doing these open response questions is remembering which way the arrows point in a food web, because otherwise I think it can get pretty overwhelming. So arrows point from the prey to the predator. So whichever one the arrow is pointing at is the predator that's eating that food. And that's going to be very important as we go ahead and answer these questions. So for the first part, it says an organism in the food web is labeled X. Identify and describe the ecological role of ecosystem X in the food web. So when they say ecological role, they really just want to know what trophic level it is. Which is it a producer or is it some kind of level of consumer? So if we remember that the arrows are pointing from the prey to the predator, we know that X is eaten by a mouse and it's also eaten by a beetle. But we also can see that there's nothing pointing towards X. X is not a predator of any sort of organism. So if we think about what types of organisms can be eaten but are not eating anything, the only thing that could be is a plant. And remember, when we are talking about plants, we're talking about producers because they produce their own food from the sun. So organism X is a producer. So that's our first part. Sorry, I got to sneeze. Ooh, sorry. Okay, so that's our first part. We've identified it. When they say describe, that's basically them asking to explain. So your answer is not complete unless you explained why. So organism X is a producer because it has no arrows pointing towards it, right? And what that means is that it's making its own food from the sun and it's not eating any other organisms. So this means that X is not eating any other organisms and is getting energy from the sun instead. All right, and we're going to get more into that later this week. Later this week, we're going to start talking about photosynthesis and how exactly is it that we can have this type of organism that's not eating anything but still able to survive. So that's going to be our goal later this week. And into next week is going to be explaining how those producers work. For part B, it says identify the organism in the food web whose population size would likely increase the most if the bat became extinct. Explain your answer. So if we're looking up here, we have bats at the top, and we're looking at what which organisms would increase. All right, so thinking about the bat, things that the bat is eating are the ones that are going to increase, right? Because they're not going to get eaten by that bat anymore. So we're looking for the bat is the predator, right? So we're looking for the prey. So in this case, the prey, if we follow these 2 arrows, would be the beetle or the dragonfly, right? Because dragonfly would be the prey and the arrow is pointing to the predator, the bat that is eating them. So I would accept either the dragonfly or the beetle as your answer. All right, so the dragonfly or the beetle would increase if the bat became extinct, right? And the explanation for this one is pretty straightforward, right? If you just think about if the bats are all gone, right, they're not going to be eating those things anymore, right? There's no more predators eating the dragonflies or the beetles, so there's going to keep overpopulating. There's going to be more and more of them because the bats are no longer in the ecosystem to eat them, right? That would cause them to increase if they're not being eaten anymore by their predator. All right, part C. There are many types of relationships between organisms, including competitive and predator-prey relationships. Identify 2 organisms in the food web that have a competitive relationship and explain your answer. So we haven't talked too much about competitive relationships yet. We are going to later on into next week probably. But a competitive relationship is just one where they're competing, right? So you're having two organisms that are fighting over something. And if you think about the fact that we're looking at food webs, the thing that they're fighting over is probably some food that they share, right? So we're going to be looking for two organisms that are eating the same food, right? And because they're eating the same food, they're fighting with each other, they're competing over it. So I'm just going to start with one organism. I'm going to start with my mouse. All right, and the mouse gets eaten by the owl and also the raccoon and also the hawk, right? So any of those three organisms can be competing with each other, right? Because all three of them are going to have to fight over access to food, right? They're all fighting over being able to eat the mouse. There's a lot of different possible answers that you could have. So if you put down a different answer from me, that's okay. Another answer that you could have that I think is pretty quick to see is the beetle gets eaten by both the mouse and also the dragonfly and also the bat. So those three things are also all fighting over the beetle. I'm going to go with my first answer, though, with the owl, the hawk, and the raccoon are all eating that same food, the mouse. All right, so if we're answering our question, the owl, the hawk, and what was the third animal? And the raccoon are in a competitive relationship because they're all fighting for the same food, which is mouse. But again, that's just one example. There's plenty of different examples in this food web. So if you put a different answer, that's okay. You're just looking for two organisms that eat the same food. All right, and finally, part D, I think this is pretty straightforward. Identify two organisms in the food web that have a predator-prey relationship and explain your answer. So all that means is we're looking at two organisms where one eats the other. And there's so many. I mean, you could list pretty much any two. I'm going to just, for my example, say the beetle and the dragonfly, right? Because the beetles are eaten by the dragonfly. But again, if you have a different answer, that's okay. So beetle and dragonfly have a predator-prey relationship because dragonflies eat the beetles. All right, but again, if you have a different answer, that's okay. And if you guys have any questions with number one, or if I've been talking too fast, or if you want to see me work it through with a different example, just shoot me an email. I'm more than happy to do that for you. This is a bit more of a complicated food web. It has more than one producer in it and a lot of different consumers, but the questions are mostly the same for part two. So we're just going to go over that very quickly. All right, so identify the ecological role of the red-tailed hawk and the elf owl. So we're looking for two things. So red-tailed hawk and elf owl in the food web. They want to know, is it a primary consumer, secondary consumer, a producer? All right, and if you watched my other video the other week, I did do this very quickly, but we're going to do it again. So let's do this. So let's start with our producers. So our producers are the plants, right? So I know that a cactus is a plant, so this is my producer. A saguaro cactus, again, that's a plant, that's a producer. And brittlebrush, that one you probably haven't heard of before, but just like the other cactuses, they just have arrows pointing away from it and not towards it, which means that it is also a producer. Oh gosh, that's the letter P. I apologize, you guys. All right, so ultimately we're looking for the red-tailed hawk, which is up here, and we're looking for the elf owl, which is up here. All right, so we do need to label up to the top. All right, so if we start at the brittlebrush, just because it's in the middle, right, it goes a lot of different directions. I'm going to try and get as close to the red-tailed hawk as I can. So brittlebrush goes to grasshopper mouse. All right, and remember, anything that eats a producer is a primary consumer. So that means our grasshopper mouse is a primary consumer. And the hawk can eat that mouse, right? So if you eat a primary consumer, we're just going up in terms of our numbers. So primary is the first consumer, right? Now we're at the second level, so we're the second consumer. And we often say that a secondary consumer, so that would be our red-tailed hawk. All right, so our red-tailed hawk can be a secondary consumer. Same thing if we went to the wood rat, right? So producer is brittlebrush. We could have followed that area over here to the rat instead, right? That would make the rat a primary consumer, right? And same thing, we can follow it up again to the red-tailed hawk. Technically speaking, you could also say that the red-tailed hawk is a tertiary consumer. And this happens a lot in nature. Remember, in science, we're always trying to put words to explain more complicated things that happen in nature, so our definitions aren't always perfect. But if we look at our primary consumer, the rat, that can go to the rattlesnake, right? That would, in this case, make the rattlesnake a secondary consumer. And if the red-tailed hawk is eating that, that makes it a third level consumer. And this one's tricky to remember, but it's a tertiary consumer, which is a third level consumer. So red-tailed hawk, if you had either of those answers, I would have accepted it. It's either or, they are both correct answers. Let's do the elf owl now, and then we'll kind of call ourselves good with this kind of confusing part. I'm going to start out with the brittlebrush again. So if we have this brittlebrush here and it goes to the grasshopper, right? That makes our grasshopper a primary consumer, right? It's eating a producer. And you can follow that arrow straight up to elf owl, making it a secondary consumer. All right. Technically speaking, this can also be a third level consumer. If you follow the brittlebrush to the harvester ant being primary, to the mantid, which is another type of bug, being secondary. Technically, the elf owl could also be a tertiary consumer. So again, if you said either of those answers, I would accept it. All right. So we're going to go down to the bottom. And let's see if I can type again. Here we go. Okay. So the red-tailed hawk and elf owl are considered secondary or tertiary consumers. I should probably say they are both considered. All right. So again, if you just had one of those, that's okay. Don't stress about it. All right. So part B, I know this is a long video. I apologize, guys. I just want to be sure we're on the same page and to help anybody that's confused. So for part B, explain how an increase in the elf owl population could affect, increase or decrease 3 other population sizes in the food web. All right, so let's go back up to our drawing. Let me see if I'm able to erase this stuff. Let's do a medium eraser. Oh gosh, this is going to take me a second. Hold on, guys. I just don't want this to get too much with me drawing on the page, so I apologize. Okay, so let's look again. We're looking at if the elf owls increased. So if we had, we had more elf owls, if the number of elf owls increase, how will that affect other things? So let's follow some arrows backwards. So if there's more elf owls, right? Elf owls eat this thing called a mantid. A mantid is a bug, all right? So if they're eating mantids, there's going to be more owls. More owls are going to eat more food, right? And eventually that food is going to start to go away. So it's going to decrease the number of mantids, right? Because there's more owls eating them. So let's make that our first one. If we go down here, let's make that our first bullet point. See if I can make this not draw anymore and go back to typing. And I apologize if you hear my dog in the background, she's chasing her tail. All right, so the mantid population would decrease because there are more elf owl predators eating them. All right, so that's one. We're going to find 2 more. All right, so we're going to scroll back up. Just like the mantid, we can actually say the exact same thing about this grasshopper, right? So more elf owls mean more predators, right? More predators means they're going to eat more and more of that food, right? So that means the grasshopper is going to decrease. And let me see if I can find the pen. Ooh. So red or pallid-winged grasshoppers are also going to decrease for the exact same reason that the mantids did. So we're going to go down. Grasshopper population would decrease, and I'm just going to copy the exact same reason I had before. Can't spell decrease correctly because there are more elf owl predators eating them. All right. Finally, we're going to have to find a third one, and I think the third one is where you have to kind of start thinking a little bit creatively. But let's go back to our mantid that we had the first time. So we said there's going to be lots of elf owls. They're overpopulating. They're going to eat all of these mantids, right? But think about, what are these mantids eating, right? They're not just by themselves. They're going to affect other organisms as well, right? And these mantids are eating harvester ants, right? So let's just look at this part that's the mantid and the harvester ant, right? So if there's not very many mantids, right, because they all are getting eaten, these harvester ants are going to be pretty happy about that, right? There's way fewer predators around, right? They don't really have to worry and hide as much, and they can start to reproduce and grow back. So there's going to be a lot more red harvester ants because there are fewer mantids around to eat them, right? They have less of their predator. So let's go back now. This is the last part. So the harvester ants population would increase this time because there are less of their predator, which is the mantid. All right, so hopefully that makes sense. You could have included other things. You could have also included, if you went off the grasshopper, you could have included, for example, the brittlebrush and things like that. So if you have different organisms, that's okay. Those are just the three that kind of come easiest to me. All right, so this is the very last thing that we're going to do. All right, so part C. A decrease in the wood rat population could lead to either a decrease or an increase in the red-tailed hawk population size. So part C, we're going to explain how a decrease in wood rats could lead to a decrease in red-tailed hawks. So let's look back up here again. I'm going to erase once more just so that it's not confusing. All right, so we have a decrease in our wood rats. There's less of them. We want to know, why is it that the red-tailed hawks also decrease? All right, and there's a lot of things that can kind of connect these two, but obviously there's an arrow right here that's connecting the wood rat to the red-tailed hawk, right? So if there's less food, right, if there's less wood rats, the red-tailed hawks are not going to be able to survive, right? They have no food to eat. All of their food is gone. So that's the reason that the red-tailed hawks would decrease. They wouldn't have as much food to eat, and they would start to starve. All right, so we're going to do it in complete sentences. So a decrease in wood rats would lead to a decrease in hawks because the hawks eat the wood rats, and without enough rats, they would start to starve, thus decreasing their population. Hopefully that makes sense. If it doesn't, let me know. All right. Part D, I think, is very tricky. And to be honest, I had to look at it for quite a long time to figure this out. So if you struggle with part D, don't feel hard on yourself. I had a hard time figuring out part D for a long time. So it wants to know, how could a decrease in wood rats lead to an increase in hawks? Right? So sometimes these interactions have more than one sort of layer to them. So we're going to erase this really quick just so because I don't want it getting in the way. Oops, not working. What is happening? Hold on. Sorry, guys. Sometimes this is tricky for me. Delete that, whatever that was. Can I just delete? Okay. Okay. So we want to know, why is it that we have less wood rats? Their population goes down. Why is it that we have more of this? All right. So if we're looking here, this one is very tricky. So my first instinct was kind of to follow it up on this direction where there's less wood rats, they're being eaten by the snakes, right? But that would mean less snakes and less hawks. So you cannot follow it that way. The only way that I've found that this question really works is because wood rats are eating brittle brush. If they're eating the brittle brush, right, less wood rats would mean that there's more of that plant. All right, so there's more of that plant. That plant is not only being eaten by wood rats, but it's also being eaten by the grasshopper mouse. So if there's more of that brush, right, of that plant, that means there's going to be more food for the mouse. That is going to increase the mouse population. That mouse also gets eaten by the hawk. So they would maybe not have as much food for the wood rat, but they would have lots more mice and therefore more food. So the population could also increase, right? And we wouldn't really know for sure which way this would go unless we were in that environment. So this is very, very tricky. And don't feel hard on yourself if you didn't get it the first time. So we're just going to write that down and then we're going to wrap this up. All right. A decrease in wood rats could cause an increase in red-tailed hawks because the wood rats eat brittle brush, right? That's that plant that we were talking about. With less wood rats, there will be more brittle brush, right? So that's this very first part that we went over. If there's less wood rats here, they're not going to be eating this brush, this plant, right? That means that there's going to be more brush, and that brush gets eaten by the grasshopper mouse. So we're going to include that. Right? When the grasshopper mouse eats brittle brush and would have a lot more food to eat now, right? It would have a lot more food available. Can't spell available today. And would have a lot more food available, meaning their population would also increase, right? And then finally, the red-tailed hawk will eat, what are they called? Sorry, grasshopper mice, and would benefit from this increase of food also. That one is particularly tricky, you guys. So if you have any questions or if you want me to walk you guys through that one again, please let me know, all right? But otherwise, I think you guys have been doing a really, really good job with this topic lately. And hopefully I know some middle school teachers do have the time to go over this. So hopefully this isn't brand new to you. But I do know that it's difficult because we're not in school together going over it. But I appreciate you guys trying your best on the open response. I believe on Wednesday, just based on how this goes, I think we're going to on Wednesday start talking about some photosynthesis and things like that, and kind of move on from there. But please let me know if you guys have any questions. But otherwise, I really hope you guys are staying safe and that you guys are doing okay. And I will try to get in contact with you guys again soon. Thank you.